Business Finance Chapter 10 examples. So we're going to go through these examples for Chapter 10 based on finding stock returns. So we're trying to figure out what the total return, the dividend yield, and the capital gains yield are for this stock. So we're going to start actually with the dividend yield. So if you remember from previous chapters, dividend yield is dividend amount divided by our initial stock price. So dividend paid divided by the initial price. The capital gains yield is ending price minus the initial price divided by our initial price. So how much did we earn on the extra price of the stock? So our capital gains yield is 12.64%. Total return is dividend yield plus capital gains yield. It is also the ending price minus the initial price, the difference between the two prices, plus the dividend paid divided by the initial price. So ending price minus initial price plus the dividend paid divided by the initial price. Or the sum of dividend yield and the capital gains yield, if we add them together, we get the same exact result. Our next example is looking for the dollar return. So we want to know how much money we actually earned on this investment. So we purchased 250 shares at the beginning of the year at the price of $104.32. The stock paid a dividend of $2.34 per share, and the stock price at the end of the year was $113.65. So what was our total return on this investment? Well, we have the number of shares purchased times the difference between the ending price and the initial price, that's our capital gain amount, plus the dividend paid per share. So the total dollar return on this investment is $2,917.50. In our next example, we bought a bond with an annual coupon rate of 5.5% 1 year ago for $1,017. The bond is selling today for $1,041 today. So we want to know what our dollar return was. Then we want to know about our nominal rate of return on this investment over the past year and the real rate of return. Okay, so first we're going to do our dollar return. So that is similar to the dividend dollar return, where it's dividend paid plus the change in price. Same formula, except we have the coupon paid. That's our dividend for a bond, plus the change in price. So ending price minus initial price. So we have a dollar return of $79. Our nominal return is that dollar return divided by the initial price. So our dollar return divided by our initial price. So we have a nominal return of 7.77%. With our real return, we use the Fisher formula to calculate that. So with the real return, we have 1 plus the nominal return divided by 1 plus the inflation rate minus 1. So we go back to the Fisher formula from a previous chapter. So nominal return plus 1 divided by 1 plus the inflation rate minus 1. So our real return on this, taking inflation into consideration, is 4.63%. In this example, we are also using the Fisher return to get what the real return is given these nominal returns and the inflation rate. We have the long-term government return. So we have 1 plus the government nominal rate divided by 1 plus the inflation rate minus 1. And then for the long-term corporate return, we have 1 plus the corporate rate divided by 1 plus the inflation rate minus 1. So we have a real return on 2.91% on the long-term government and 3.3% on the long-term corporate. We now are looking at the standard deviation and variances for a series of returns. So we have stock X and stock Y. We're starting with the arithmetic average returns, then the variances, and the standard deviation. So our actual return for X is being pulled down from our table. So our actual return, and we want to display those as a number instead of as a percentage for this review. So we're going to add all those together, so sum all of our returns so that we can get the average. Our average return is our total divided by the number of periods we have, which is 5. Our average return, so it comes from here. We're going to lock that cell because it's the same all the way down. And then our deviation is the actual return minus the average return. We square our return. So to the power of 2. And then we add the sum of all of our squared deviations. The variance is the square of deviations divided by the number of periods minus 1. So we have the sum of all the periods divided by, we have 5 years, so 5 minus 1 is 4. So divided by 4, that gives us the variance, and the standard deviation is the square root of the variance. So we're going to use the formula square root to the variance, and we get the square root. Okay. Then we would do the same for y. Bring down our actual return for y. Change that to a number from a percentage. Add them together. And divide that total by 5 to get an average. Then the average return, we're going to lock that cell. And then the deviation is the difference between the actual return and the average return. So how far are we out from the average? And then we square that amount for our square deviation. add those together. And then variance is the same. We're going to take the total of the squared divided by 4. And then we're going to get the square root of that number for our standard deviation. Our next example, we're going to do a similar thing, but we're going to be looking at the historic number of large company stocks and T-bills between the periods of 1973 and 1978. So if you remember, Chapter 10 textbook has information about a 92-year span of investments and the average returns for those investments each year over the 92 span of years. So we're going to start with the average and then the standard deviation. So the actual return of large company stocks total. And since we're looking at 7 years, we're going to take our total divided by 7 to get our average. So our average return, locking that cell. And then the deviation, the difference between the actual and the average. And the deviation squared. So we have the variance, which is the sum. Oh, we've got to sum our squared deviations first. So that is the sum of our squared deviations divided by the number of years minus 1. So we have 7 years minus 1, so we divide by 6. The standard deviation is the square root of the variance. So I updated my formulas because it was actually 6 years instead of 7 years. So it's 6 for the average and 5 for the variance. So let's do the T-bills. We'll notice that because T-bills have less risk, their average return doesn't have as much variance as the return of stocks does. So we have 6 years of information divided by 6 to get our average. Deviation is the difference between those. And then we square the deviation and total. Our variance is that divided by 6 minus 1 because it's 6 years, so 5. And then we square that to get our standard deviation. The next item says the average observed risk premium. So our average observed risk premium. So we're going to look at now what they are added together. subtracted. So the large stock return minus the T-bill return, that's the risk premium. We'll add those together and get our average, which is the total divided by 6. So our average and then the difference between the two, or the difference between the two. And the deviation squared, that comes to the power of 2. You get a very different result if you do it times 2. Add those all up. And our variance is the squared deviation divided by 5 for this problem. And then we get the square root of the variance for our standard deviation. So what does this all mean? So we have average returns for large company stocks and T-bills. We've done the standard deviation for the returns and the observed risk premium in each year for stock versus the T-bills and the average risk premium over this period. So what D asks then, is it possible for the risk premium to be negative before an investment is undertaken, and can the risk premium be negative after the fact? So we're looking at these risk premium here. So generally before the fact, most risk premiums will be positive because investors demand compensation over and above the risk-free rate. So the risk-free rate is what the T-bill rate is because they're generally risk-free. In order to invest their money in risky assets, they want the risk-free, they want the return to be higher. After the fact, we can have a negative return. So we're looking at historic returns right here. So if the nominal return is low or negative and the risk-free rate is higher, the combination of these two can make for a negative risk premium.